Today we'll discuss some of the material in Chapter 2. There are a lot of important acronyms in this chapter, so we'll have some practice with those. We'll go over energy and nutrient density, and finally I'll introduce you to MyPlate. The acronyms begin with DRIs. DRI stands for Dietary Reference Intake. These are all of the recommendations made by the Food and Nutrition Board. The DRIs include the EARs, RDAs, AIs, ULs, EERs, and the AMDRs are not exactly a DRI. This image in your book summarizes the relationship between some of the DRIs well. So I'll ask you to pause the video to read the questions on your own and work on them. Then we'll go over the questions together. Okay, pause now. So the first question was to describe the axes. On the left axis, we have the percent of healthy population at risk of inadequacy, and on the right, we have the percent of population at risk for toxic overdose effects. These are opposite ends of a spectrum. The top is 100% and the bottom is 0%. The next question was about the DRIs that fit the description. The highest level of intake would be the UL, or upper level, here. The lowest level would be the EAR, or estimated average requirement. So UL is greater than EAR. The next question was about AI. Adequate intake is between RDA and UL. So AI exceeds recommended dietary allowances, but is under upper levels. This will make more sense once you understand what each acronym means. EARs, or estimated average requirements, are an average. Another word for average is 50% percentile. And EARs fulfill the needs of half the population. We have EARs for nutrients that have good biomarkers in the body, producing a very measurable effect. RDAs are recommended dietary allowances. RDAs are greater than EARs because they meet the needs of more than 50% of people. They meet the needs of about 98% of people. This is how much of a nutrient a person should aim for to prevent diseases, and it's based on the same biomarkers as EARs. AIs are adequate intakes. These are a little different because they are set for nutrients without good biomarkers. These are things that we know promote health and in what amounts, but there's no single direct measurement for their effect in the body, like fiber or omega-3 fatty acids. ULs are upper levels. These are set for nutrients that could harm a person when taken in excess. There are also EERs, or estimated energy requirements. These are in the form of calories needed per day, and AMDRs. These are in a range of percentages needed for each energy-yielding macronutrient. Since there's no specific amount recommended, just a proportion, the AMDRs are not a DRI. So you should now be able to distinguish all of these acronyms from each other and be able to define them. Let's move on to densities, beginning with energy density. This one may be obvious. To calculate the energy density, you divide the calories in the food by the grams of food, so kilocalories per gram. Something high energy density would have a lot of calories per weight, whereas something low energy density would have few calories per weight. Things with a lot of fiber or water would have low energy density. In contrast, nutrient density compares the amount of nutrient to the calories in the food. Something that is nutrient dense would have a lot of the nutrient for the amount of calories, while something low nutrient density would have few nutrients per calories. Soda is a good example of a low nutrient density food because there are virtually no nutrients in it. In other words, it's an empty calorie food. Let's do some comparison. A whole glass of milk has several macro and micronutrients represented as percent RDA here, and a glass of Coke has calories but almost 0% RDA in any nutrient. Whole milk is the nutrient-dense option. The same goes for 2 nutrient-dense oranges versus a non-nutrient-dense chocolate bar. It might be challenging to set up your diet looking for nutrient-dense foods, but there's some guidance about how to do that. The dietary guidelines for Americans are set up to encourage our intake of fruits, vegetables, whole grains, some dairy, proteins, oils, and foods rich in fiber and vitamins we tend to lack, vitamin D and calcium. These guidelines also stress the importance of physical activity and discourage the intake of foods we get too much of: sodium, fats, sugars, refined grains, and alcohol. A lot of this information is illustrated in MyPlate, the USDA's suggestions for healthy eating. MyPlate evolved from the food pyramid of the 90s. Make sure to explore the MyPlate link that I've provided in the folder. The MyPlate suggestions are a good start to making healthy meal choices, but there's more information out there. One of the biggest sources of food information available is the nutrition facts labels on food. On the nutrition facts panel, you can find the calories in the food, the size of a serving, and the percent daily values for many nutrients. The fat, cholesterol, sodium, and carbohydrates have a percent daily value, but the sugars and proteins do not have a percent daily value. You can find some additional information on some, but not all, vitamins and minerals. And you can find the ingredients listed in descending order by weight in the food. You may be wondering where the percent DV value comes from. Daily values, or percent DV, is based on a combination of RDIs and DRVs, which I'll get to in a second. The daily values are based on a 2,000 calorie diet for healthy adults. If the label lists 15% for calcium, it means that one serving provides 15% of the calcium you need each day. The label doesn't represent the needs of young children or women who are pregnant or breastfeeding. The RDI, or reference daily intake, that I mentioned are a set of recommended nutrient intakes that are specific for a life stage. For example, young women require more iron than other groups, so their RDI for iron is set high. The DRV, or daily reference values, are a similar set of values for energy-yielding macronutrients and nutrients that do not have RDAs. The daily value takes the highest RDI available and reports an upper limit for nutrients that are known to be overeaten, such as sodium. With that information, you can get started on your first real assignment for the class, the labels assignment. Here, you'll look more in depth at nutrition facts labels and your perception of how healthy a food is. Hopefully this video has helped you understand all of the acronyms in the chapter, helped you understand the difference between energy and nutrient density, and has introduced you to using MyPlate, which will be a major part of the diet analysis project in the class.